little few details about that. So like I said before, with sodium it's got one electron he wants to give away. Chlorine wants one. So you see his electron configuration, he has 1 in the highest level, whereas this guy has 7 in the highest level because of the 2 and the 5. So he wants one, he wants to give one, and that's what happens. And since he gains one, or loses one rather, he becomes positive because he loses a negative electron, and he takes an electron, so he becomes negative, and then they are attracted to each other. So sodium is going to behave just like neon. It doesn't become neon because we're not changing the protons, and chlorine is going to behave just like argon. So they're both noble gas configuration. Okay, so these guys are going to form an ionic bond, a bond between ions. So NaCl, what we just did is the chemical formula for some things. Here you see a close-up of some sodium chloride. And this is what it looks like if we were to really zoom in. So alternating positive cations and negative anions. You can see it's a 1-to-1 ratio. And that's what we just did. We figured out the ratio that they combine in. So again, here's our sodium. He's lost an electron, so 17 pluses, 18 minuses. Minus 1 charge. Whereas our sodium guy, 11 pluses and 10 minuses, so a plus 1 charge. Okay, so 2 things we need for an ionic compound. A cation and an anion. Or another way to put it, a metal and a nonmetal. And again, we always put the metal first, the nonmetal second, just like the periodic table has them. Okay, so collectively, since we have equal amounts of pluses and minuses, they cancel each other out, so our compound is going to be neutral. Now the cool thing about ionic compounds is usually their component parts look nothing like the ends. So here I have some aluminum metal, very shiny, malleable. Here I have some bromine gas, very deadly. Mix them together, I get something that looks completely different. Just like sodium chloride. Sodium blows up. Chlorine, that's another lethal gas. You put them together and you get table salt. Then you can eat it. Okay, so chemical formulas are what we just made. They are called formula units. So if I have something like NaCl, this is a formula unit. Now some textbooks will call this a molecule, like your biology textbook might refer it as a molecule. Not really a molecule, it is a formula unit. We'll discuss the differences later on. Alright, so now you guys have done it in a group with the discs. On the test, obviously, you're not going to have that. You're going to have to do it with paper and pencil. So when you do electron dots with paper and pencil, let's say we have, let's do sodium. What haven't we done? We'll do nitrogen, even though we already did this one. So let's say we're combining sodium and nitrogen. So my first step is going to be write the electrons for sodium. So he's in group 1, so he has 1 electron. And then for nitrogen, he has 5 because he's in group 5. Okay, so that's my first step. So we've said now that sodium doesn't want his electron, but nitrogen does. So I'm just going to take it away from him. And I'm going to move that to nitrogen. So I take sodium, move it to nitrogen. Okay, now we have 6, but he wants 2 more. So that means I need to bring in another sodium, and he's in group 1, so he has 1 electron. He doesn't want this one, but nitrogen does. So again, I'm going to take this one away, give it to nitrogen. Oops. He wants 1 more, so I got to bring in 1 more sodium with his 1 electron. And he doesn't want this one, nitrogen does. So I'll take it from him and give it to him. Okay, now this guy has 8. These guys have lost all of theirs, so now I'm done. So when these guys combine, I'm going to combine in the ratio of 1, 2, 3 for every 1 nitrogen. And that's my ionic compound. Alright, so at your desk right now with you guys, try and do A and B here. Alright, so potassium is group 1, oxygen. Whoa, what's going on? Stop doing that. Dang. Alright, so potassium's group 1, oxygen's group 6, so 1 electron, 6 electrons. Okay, potassium doesn't want his, so he's going to give it to oxygen. Now he has 7, but he wants one more, so we bring in another potassium who has 1 electron. He doesn't want it, so we're going to take this guy away from here and give it to here. Okay, so now both potassiums are empty. Both potassiums are empty. Oxygen has its 8. So for every 2 potassiums, I have 1 oxygen. And again, we would read this as potassium oxide. Okay, now magnesium group 2, so 2 electrons. Oxygen group 6, 6 electrons. So I'm going to take 1 from magnesium. Actually, I'm going to... What? I wrote the wrong thing. Should be nitrogen group 5. Alright, so now we'll take them from magnesium. So I take 2 from magnesium, I give them to nitrogen. But now he has 7, he wants some more. So I got to bring in another magnesium. He's group 2, so 2 more electrons. Okay, now I'm going to take those 2. Just kidding. I'm only going to take 1. Because now this guy's full. This guy has 1 more to give, but there's no nitrogen, so now I need to have another nitrogen. Alright, he's group 5, so he's going to come in with his 5 electrons. Now I can take this 1 from magnesium and give it to nitrogen. But now he wants 2 more, so now I need another magnesium. Comes in with his 2 electrons because he's group 2. And now I can take them from him. And now we're all done. These guys are filled up. These guys are filled up. So this tells me for every 3 magnesiums, I need 2 nitrogen. Alright. Alright, now a few things about ionic compounds before we go. Very strong bonds between ionic compounds. So since they do have strong bonds, they're solids at room temperature. And they're also going to form orderly arrangements, which we'll see in a second. Since they have very strong bonds, they have a high melting point. Because if you want to melt something, you got to break those bonds. So they're going to be melting about 500, 600, 700 degrees Celsius. Now when they're solids, they don't conduct electricity because the electrons are not free to move about. But if I melt them, then the electrons are free to move. And if I dissolve it in water, this is what I get. So an ionic compound in water, the sodium or the cations and the anions break apart. They're free to move, and so now the electrons are free to flow. So ionic compounds conduct when they're melted or when they're dissolved. And then these are just some examples of some crystalline solids.